We've been making very steady progress learning the different programming concepts in Python, and generative AI tools have been very helpful in our learning so far. You've seen that prompt engineering with chatbots such as ChatGPT and Google Bard have been very useful, especially to help us debug issues and explain basic concepts and allow us to explore what operations can be performed on different types of data. What I've noticed is that once you know the basics of a language, that's when generative AI tools really become amazingly helpful. Once you know enough that the code generated by these tools can be understood by you and you know how to tweak and debug that code, well, you'll find that you'll code so much faster and so much more efficiently using Gen AI. And you'll see some of this in this demo on classes. So far, we've been exposed to the functional programming aspects of Python. Now we'll work with the object oriented programming aspects, and we'll work with classes, and we'll create and instantiate objects from these classes. Classes are just blueprints for creating objects. Classes are used to represent entities in the real world. These entities have properties, and each entity has its own unique set of properties, and each entity can perform a set of actions. The properties and actions that an object possesses is defined in the blueprint of the object, and that is the class. You'll find that in this demo, beyond a few basics, most of the code will be generated using ChatGPT or Google Bard. First, let's define our very first class, and this class is going to represent a car. In Python, you use the class keyword to define a class, and the name of the class is car with C in uppercase. After the colon, you have the body of the class, and here I've defined a class with no body, and that's why I've specified the pass keyword there. Pass simply means there's nothing here, just move on. Once we've defined this class, let's go ahead and instantiate two objects of this class, and here is how you instantiate objects in Python. The first object is on line 1, and I assign that object to the car1 variable. The second one on line 3 is assigned to the car2 variable. Observe the syntax of how we instantiate classes. I use the name of the class car, and then I have open close parenthesis. Now there's nothing within the parenthesis because this class does not take in any input arguments for initialization or in its constructor. You'll understand what those mean in just a bit. These are two different objects occupying different memory locations in our program, and they're completely independent of each other, but they're both of type car. Now let me show you that these are actually independent objects. If you just type out car1, you'll be able to see the memory location for this object. This is where car1 lives in memory. And if you were to compare this to car2, you'll see that car2 has a completely different memory location. Car1 and car2 are both instances of type car, but they are different objects. Changes that you make to car1 should not affect car2 and vice versa. Now let's check to see what type each variable is. Type of car1 should tell you that it's of type car. This is our own custom class that we have defined. And the same is true for type of car2. Type car2 is also of type car, but remember, it's a different object. We know the two instances point to different memory locations, but let me assign some properties to car1 and car2 and show you that the properties are different. I'm going to assign the make property of car1 to be Honda. So when you access car1.make, you should see Honda. When you assign values to properties in this way, you'll find that the properties exist on only the car instance that you assigned it to. If you try to access car2.make, you'll get an attribute error. Car object has no attribute make. Now let's say you assign the model property to car2. So you set the model of car2 to be Civic. Now if you access the model property of car2, you should get back Civic, but this property is not present in car1. Car1.model, well, it returns nothing. You can see that the car object has no attribute model. There are two things to observe here. The first thing is that car1 and car2 are independent objects, and properties you set on one are not available on the other. But another thing to note from here is that really you want every car object to have its own make and model properties that you can tweak independently. Well, how do you specify this? You specify the properties and actions you want for every car as a part of the car class template. And how exactly can you do this? Well, let's turn to our trusty assistant, ChatGPT. Here's my prompt for code generation. I want to create a Python class called car and initialize it with a few properties that all objects will have. Can you help me define the class? Now, here I don't indicate what properties I want the car class to have. However, in your case, if you have some specific properties in mind, you should add that to the prompt. In addition, I tell ChatGPT I just want the initialization for now. I haven't yet figured out what methods or actions the car will perform. Observe that I'm constraining the output that may be produced by ChatGPT. If I don't do this, it'll give me a fully fledged car class and it'll be too much to parse as we are learning classes. Here you can see that ChatGPT has produced the code for a car class for me. Let's copy this code over, and once I paste it into Jupyter Notebook, I'll explain what's going on here. You can see that we redefine the car class using the class keyword. Now, within the car class, there is a function that has been defined. You know it's a function because we've used the def keyword. The name of the function is underscore underscore init underscore underscore. And this double underscore is referred to as dunder. So this function is actually dunder init dunder. In the generated code, ChatGPT had also provided an explanation for what this init method does. The init method is used to initialize the properties of an object when you instantiate the object. If you worked with other object oriented programming languages such as Java, the init method can be thought of as the constructor of the class. The init method takes as an input argument four properties that we'll instantiate each class with: make, model, year, and color. Now, there is the first input argument, self, which is kind of mysterious, and really it was very confusing to me when I first studied Python. But observe that we use the self input argument to assign the make, model, year, and color properties for the objects. I'll explain what self means here, and we'll also get additional explanations from ChatGPT in just a bit. Now, remember, I said that a class is nothing but a blueprint or a template for all of the objects that you instantiate of the class. The self input argument that you see here to the init method is essentially a reference to the current instance of the class that you're instantiating. You'll instantiate several instances. Self will always refer to the current instance. We then use this self variable to set up the properties of that instance. Self dot make, self dot model, and so on will set up the corresponding properties for the instance of the class that you're creating. The values of these properties will be set to the input arguments that you've passed in: make, model, year, and color. I'm going to add in another line of code here to this init method. Whenever the init method is invoked, I'm going to print out car initialized and then print out the make, model, year, and color of the car. Now you'll be able to see how this init method is automatically invoked when you instantiate an object of this class. Let's set up two car objects. I'm going to store them in variables Camry car and Civic car. Observe now that the way I instantiate these car objects is different. On line 1, I instantiate the first object, but I don't have an empty pair of parentheses. Instead, I pass in the properties for that particular object. Toyota, that's the make. Camry, that's the model. 2022 is the year, and the color is blue. The second car object defined on line 3 has a different set of properties. It's a Honda Civic, year 2019, and the color is red. Now, these properties correspond to the input arguments of the init method. So, Toyota is the make, Camry is the model, 2022 is the year, and blue is the color, and they match up with the input arguments in init defined on line 2 of the previous code cell. But you might ask, what about self? Where does that come from? Well, we'll use ChatGPT to understand that in just a bit. Self is actually passed in automatically. As I instantiate these objects, note that the print statement that I call within the init method of the car class is executed and the details of each car is printed out to screen. I did not explicitly invoke the init method. When I instantiate an object of type car, init is called automatically, and this is something that you need to keep in mind. We've instantiated two different objects occupying different portions in our program's memory. Here you can see the memory location for our Camry car class, and here you can see the memory location for our Civic car class. Thanks to this init method that we have defined and which we use to initialize car objects, you can try to access the make, model, year, and color for all car objects, and all of these will have valid values. So try accessing Camry car's make, model, year, and color, and you can see that you get the information that you initialized. The same with the Civic car. Now we pass in an input argument called self to the init method, but self is not actually a property on any of the objects that we've created. If you try to access self, you'll find this attribute error. So let's turn to ChatGPT and get more clarification on this self input argument that was passed to the init method. And ChatGPT actually explains this beautifully. Self here is a variable that refers to the instance of the class itself. And it's a convention in Python to name this first argument self, and you can actually name it anything else. And the reason why the self is needed is because you need to refer to this self variable in order to be able to set up the variables and attributes for that particular instance. Self has to be passed in as an input argument to the init function and to any other function that you define in your class. Python automatically passes in the right value for self when you instantiate a class or invoke any methods on the class. Let me show you this. Let's define the init method and let's not specify the self input argument. This is just a test car that we've set up. Notice that the init method has no input argument. Now, if you try to instantiate the test car, you'll encounter an error. Init takes 0 positional arguments, but 1 was given. Where was that 1 argument passed in? Python did it automatically. While calling the init method, Python passes in the current instance of the object as an input argument, but we haven't specified any input arguments to init, and that's why this fails. Now let's tweak our code a bit. I'm going to pass in a single input argument and I'm going to name it any var name for self. Remember, the convention is to call this input argument self. I've just given it some other variable name. And using this new variable name, any var name for self, I set the property attribute for the test car to be equal to initialized. Now, even with this different variable name, if you try to instantiate the car will be initialized successfully. Every Python method that you define in a class has to have one input argument at the very least, and that should be the self argument. You can call it anything you want, but the convention is to call it self. And this property attribute that we initialize for the object, you can access it by using the dot. Testcar.property will give you initialized. Now that we have a basic car class with some properties set up, let's see how we can improve upon this class by adding more functionality to this class. I'm currently on the conversation where ChatGPT has already generated a car class for me. So I'm going to continue the conversation. Please update the code to have the car track its current running state. So at any point in time, we should know whether the car is running or not. Also, I want ChatGPT to specify a start and stop method or function on the car to start and stop the car respectively. Now, ChatGPT will generate some meaningful code for me. Our query was reasonably straightforward. What I'm going to do is copy this code over and tweak it to suit my needs. I'm only interested in the class definition, so I'm going to get rid of all of this extra code here at the bottom, and I'm left with a class definition which has an additional is running property. You can see that on line 5. However, the class definition is a little different. Notice that the init method only contains the make and model as input arguments. I'm going to change this. I'm going to re-add year and color, and I'm going to make sure that the year and color properties of the current instance are also initialized. I'll also quickly update the print statements that are in the start, stop, and get info methods, and then we'll look at all of these methods in detail and understand what exactly they do. First, let's take a look at the init method of this newly defined car. Init is the same as before with one change. On line 7, there is an additional property that every car object has. The is running property that is initialized to false at init time. If you look on line 2, when we instantiate a car, we only specify the make, model, year, and color. We do not specify whether the car is running or not. By default, is running is false. Next, on lines 9 through 14, we have the start method. This is the method that we'll invoke to get the car to perform the start action. This is what will cause the car to start. Now, what does it mean for the car to be started? If the car is not already running, so if not self dot is running, so if is running is not already true, we'll print out the screen starting the car and we'll print out the details of the car. That's on line 11. And then we'll actually make the is running property equal to true. So self dot is running will be set to true. If is running is already true, then we'll print the screen on line 14. The car is already running. Observe that the start method takes in just a single input argument, and that is self. That is the current instance that Python will pass in automatically, which means when we invoke start, we specify no input arguments. Next, ChatGPT defined for us the stop function on lines 16 through 21. Stop also takes in just self as an input argument. Python will supply that and we'll just call stop with no arguments. Within the stop method, we'll check to see whether is running is true. If self dot is running, if that's true, then we'll set is running to false. Otherwise, we'll say the car is already stopped. The get info method defined on lines 23 through 25 will return details of the car. It'll just return a string which gives us the color, year, make, and model of the car, and it'll tell us whether the car is running or stopped. Now that we have a functional car, let's take it for a test drive. I instantiate a Civic car. It's a Honda Civic, year 2019, color red. Here is the memory location of the Civic car. Now, civic car.start will actually set the is running property to true and it will print out starting the car. Civic car.start, if you invoke that once again, it will tell you that the car is already running. The car is running. Let's go ahead and stop the car. Call civic car.stop and it will stop the car and print out an appropriate message. Is running will now be false. If you try to stop the car once again, you should get the message saying the car is already stopped. And if you want the details of the car and the current state of the car, you can call civiccar.getInfo and you can see this car is a red Honda Civic and it's stopped. Let's go back to ChatGPT and let's have it enhance the functionality of our car even more. So I continue the conversation from where we left off. So in addition to the is running property, could you add a speed property to the car? Now I write my prompt in this way to ensure that the is running property is still present. And in addition, I want a new property and I specify exactly what that property is, speed. I want the car class to have some new methods. So I ask ChatGPT to add an accelerate method to increase the speed of the car. Observe that I do not specify what the signature of the accelerate method should be or how the speed should be increased. ChatGPT figures that out. I also want a brake method to reduce the speed of the car. Once again, I don't specify the signature of the method or what input arguments it should take in or how the speed should be reduced. And then I have one more instruction. If the speed goes below 0, stop the car. So this is this additional functionality that I want in my car class. Let's go ahead and see what ChatGPT generates. What I'm going to do is I'm going to copy the code over and tweak it based on the little changes that I want. The main change I'll make is notice that this particular car just has make and model as properties. I also want year and color as properties. So let's copy the code over, paste it into Jupyter Notebook, and I'll make changes. ChatGPT has given me examples of how I can instantiate the car class and invoke the methods. I don't need that. We'll do that in a bit. Notice that it only has specified the make and model of the car. So I'm going to make changes to include year and color as well. Let's take a look at the init method of the newly updated car class. Notice we have an additional property, speed, on line 8. Self.speed is initialized to 0 when the car object is first instantiated. In addition, is running will also be initialized to false. This makes sense. The init method seems to be in good shape. Let's look at the next method, the start method. I'm just going to make a little change here to the print statement so that we print out the make, model, year, and color of the car in start. And I'll do the same for stop as well. Now let's take a look at the code for both of these methods to ensure that the code is correct. This is extremely important. When you use code generated by ChatGPT or Bard or any Gen AI tool, ensure that you test the code for correctness. In the start method, if the car is not already running, if not self.isRunning, then we'll set is running to true Otherwise, we'll print car is already running. That looks good. In the stop method, if the car is already running, that is, if self.isRunning is true, then we'll stop the car, that is, we'll set is running to false, and notice that ChatGPT correctly resets the speed to 0. This is not something that we had explicitly specified, but because the class that we generated was simple and straightforward, ChatGPT actually recognized that if the car is no longer running, its speed should be 0, and it correctly added that bit of code. Next, let's take a look at the accelerate method. Observe that ChatGPT has correctly passed in an input argument to accelerate, even though we didn't specify this. The accelerate method thus takes in the amount by which the car should be accelerated. And here, notice ChatGPT once again is quite sensible. It checks to see whether the car is running before it increases the car's speed by the amount. Only if self.isRunning is true will the speed be incremented by account plus equal to account. Next, let's take a look at the break function. ChatGPT gets many things right here, but this function has a subtle bug. Let's see the things that ChatGPT got right. If self.is running, so only if the car is running will the car be brake. We decrement the speed by the amount passed into the brake function. If the speed goes below 0, the speed is reset to 0. Again, this is very sensible coding, but there should be another line of code here. When the speed is reset to 0, self.is running should be false. Remember, we had asked ChatGPT to stop the car if the speed falls below 0. Let's say we brake to such an extent that the speed becomes exactly 0, we won't stop the car. Then we'll have to call the stop method to stop the car in that case. There are, of course, many ways in which you can improve this car class, but for now, we have a fairly decent functional class. I'll just get rid of this getInfo method here at the bottom. We don't really need that. And now we're ready to take this particular car for a test drive. Let's instantiate a Tesla car. We specify the make, model, year, and color. Let's start the car, Tesla car.start. It has started, and now we should be able to accelerate the car. So let's go ahead and call car.accelerate, and I want to accelerate to 30 miles per hour, and that's the current speed. Let's accelerate the car yet again by 20 more miles, and you'll see that the current speed will now be 50 miles per hour. Accelerate needs you to specify the amount by which to accelerate. If you try to call accelerate without specifying that input argument, well, you'll get an error, and this should be totally expected. Now that we've accelerated the car, and let's brake by 10 miles per hour, so our current speed has fallen to 40 miles per hour. Now let's brake once again by 45 miles per hour, and the car has come to a stop because the speed has gone under 0. With the car stopped, if you try to accelerate the car by whatever miles per hour, we have some checks in place to prevent this. The car needs to be started before accelerating. That's the message that we get. So let's start the car again, and now the car is started, but its speed is still 0. Now we can accelerate the car. Let's take it up to 20 miles per hour. This is where we left off in the previous video. We restarted our Tesla car using Tesla car.start, that you can see that the second to last cell, and then we had accelerated the car to 20 miles per hour. So the car is currently running at 20 miles per hour, and you can actually access these properties on the Tesla car to see what values they have. Note that Tesla car.isRunning is true and Tesla car.speed is 20. That is 20 miles per hour. Now, when you have access to the properties of car objects, you can actually manipulate these properties directly instead of going through methods. And this is actually a bad thing. When you work with methods, the method ensures that your car is always in a good state. When speed is 0, isRunning is set to false. That's an example of making sure that your car is in a good state. Let me show you how accessing these properties directly can get your car in a bad state. Tesla car.is running. I've accessed this property and I set it to false. So what we have right now is that the car is not running, but its speed is 20, which doesn't make any logical sense. Essentially, the properties of the car are such that they're giving you conflicting information. This is what it means for the car object to be in a bad state. This is possible because we are accessing and modifying the properties directly. Maybe you don't mean to, but you can end up doing this inadvertently. Let's see if ChatGPT can help us with a way to fix this. Here is my prompt to ChatGPT. I was able to access the is running, speed, and other properties on my car objects directly, and now the properties do not have the right state. Is there a way to ensure that all the properties can only be accessed via methods? Is there a way to enforce this? Now, for those of you who've programmed in Java or C Sharp, the answer might be obvious: make the properties private. I'm curious as to whether Python has some such thing. And actually, this explanation from ChatGPT makes it clear that Python does not. Python does not have strict access control like some other programming languages. However, you can follow conventions and use something called name mangling to make it more difficult to access attributes directly from outside the class. So while there's no concept of a class having private attributes or properties, you can use double underscores or dunders as a prefix for attributes you want to make private or less accessible from outside the class. And when you use double underscores for your properties, that's actually name mangling. And I'll actually show you what that means because it's much easier to see than read. If you look at the example code that ChatGPT has generated, notice that all properties now start with a double underscore. Within the class, the property can be accessed as is, but these properties will not be easily accessed outside of the class. Now, instead of just copying this code over, let me just add double underscores to the class that we were working with in our Jupyter notebook. So this is the same class as before, but I've redefined it so that all properties start with a double underscore prefix: self dot underscore underscore make, self dot dunder model, self dot dunder year, and so on. Now, within the class, these properties can be accessed by their name directly. For example, in the start method, I can access self dot dunder is running. So that's perfectly valid. Also, outside of the class, these properties will not be easily accessible. I won't go through the rest of the code here. It's the same code as before, except that all of the properties now have the dunder prefix. Now, with this newly defined car class, let's instantiate the Tesla car once again, the Tesla Model 3 year 2021, color black. Then I call Tesla car.start and I accelerate to 56 miles per hour. And here you can see the car is instantiated and the car speed is 56 miles per hour. From outside of the class, let's try to access the is running and speed properties. We'll access them by specifying the dunder or the double underscore, but observe that we get an error. The car object does not seem to have these attributes. Well, they do exist inside of the class, but I can't access them from outside of the class. And the reason for that is name mangling. And we'll actually understand this if we take a look at the dunder dict dunder property that is available in every object. This is basically a dictionary that gives you all of the properties for that particular object. Notice how the property names are actually different. Their names have been mangled. The dunder make property is now underscore car dunder make, and so on for each of the properties. So it's not that the properties are no longer accessible, but it's hard for someone to inadvertently change a property without using a method. For example, you could access the make of the car by using underscore car dunder make, and that will give you the make of the car, which is Tesla. So the name mangling does not actually make the properties private, but it prevents you from inadvertently modifying those properties, and so you won't get your objects in an inconsistent state by mistake. But of course, if you actually go in and change the property, well, no one can guarantee how your objects will be. Now you can see that if you just type out Tesla car, the object, you get information about the memory location where that object is stored and some other detail, the fact that it is of type car. Let's say you were to print Tesla car, well, you get the same information. This output that we get from invoking the print function tells us nothing about what the object is like, what properties the Tesla car has. And really, that's something that's nice to have. When you print a dictionary, you actually get the contents of the dictionary. You don't just get a memory location and information that this is a dict, right? So there should be some way to get that information when you invoke the print function. Let's turn to ChatGPT for help. Let's describe our situation accurately. I've instantiated a car object. I want to be able to call print and Tesla car and have it display something meaningful. Is this even possible? And it seems like it is. It's possible to make our car class more user friendly by defining a custom string representation for instances of the class. And for that, you need to override the dunder stir dunder method in your class, which allows you to define what should be displayed when you call print and that object. Now, don't worry about the term override here. That has to do with class inheritance, which we won't be covering here in this course. But essentially, all classes in Python derive from a base class implementation, and this stir method is actually already implemented in the base class, but you have to redefine it in your class so you can have a custom string representation for objects of your class. And here you can see an example of how to define the stir function. I'm just going to copy this particular method over and I'm going to update my car class here and add the dunder stir dunder method. This is a special method in Python. Just like init is a special method which is called when an object is instantiated, stir is a special method as well, and that's why it has those dunders. Here we return a string representation of what we want displayed when we pass in objects of this class to the print function. The string representation has the color, year, make, model of the car, and whether it's running or not. Re-execute this code cell so that our car definition is updated. Let's re-instantiate the Tesla car, start and accelerate it. I'm just going to re-execute all of these code cells by hitting Shift Enter or Command Enter. And now I come to the print function. I'm going to print Tesla car and notice I get my custom string that I had returned from the dunder stir dunder function. So far in our journey learning Python, we've encountered a number of different errors, starting with the name error. Let's say you call print on a variable hello world and you haven't defined the hello world variable. Well, this is the name error that we encountered early on in this course. A different error we saw along the way was when we tried to divide a number by 0, as I've done here. Division by 0 results in a different error, the zero division error. Let's look at a couple of more errors that we've seen before. Let's say you have two variables, one contains a string, another contains an integer, and you try to add those two together, var1 plus var2. This results in a type error which says you can only concatenate strings to strings, but you cannot concatenate strings with integers. Well, that's quite clear. But what if you try to do the opposite? You try to add var2 and var1. Here you're trying to add a string to an integer. This still results in a type error, but the message is different. You get unsupported operand types for plus, integer and string. So you can see that there are different errors for different use cases. And the moment your program encounters any of these errors, the program will stop executing and will not move forward. And this is an important detail in programming. You have to learn how to handle errors gracefully so that your program does not terminate when an error is encountered. Let's consider a very simple function here. I've defined it. It's called add and it takes in two numbers, num1 and num2. Now, num1 and num2 could be numeric values or they could be strings. In order to perform this addition, we first convert them to floating point values using the float function. So result is equal to float num1 plus float num2. We then print to screen on line 4 the sum of num1 and num2 is a result, and we return the result from the function. So a very simple function, but things can go wrong here as well. Now let's ask the user to input two numbers and then invoke the add function and display the result of add. We have two input functions here asking for the first number and second number. Let's say the user enters 45 and 87. Well, that will give us a reasonable result, and the result of adding these two is 132. But instead of entering numeric values, let's say the user now enters 45 and then the character T, we get an error. Notice that this is a different type of error. This is a value error that says could not convert string to float. So the string T could not be converted to a floating point value, and that's why the addition could not be performed and the program just stopped. Let's say this was a production system that you were building. This error would simply not be acceptable. Your program has to be able to gracefully deal with this error. Let's turn to ChatGPT and get its help on how we can do this. And again, I make my prompt quite descriptive so I get a specific and meaningful answer. Here is a function that I have defined and I've put in the add function there, and I explain the problem to ChatGPT. If the users enter non-numeric inputs, this just fails. How can I handle this error gracefully? And ChatGPT generates a bunch of code and some explanations. ChatGPT very correctly tells me that you can handle the possibility of users entering non-numeric inputs gracefully by using exception handling in Python. Specifically, you can use a try except block to catch any exceptions that may occur while trying to convert inputs to floats. And this is key. All of the errors that we've encountered so far while running Python programs, those errors are actually exceptions that are raised by Python code. Raising an exception allows Python code to indicate that something wrong has happened, and this is something that you ought to pay attention to and handle in some specific way. And the way you handle exceptions gracefully is by wrapping your code in a try except block. Notice the try except block here. I'm going to copy this bit of code over, and this is how we're going to rewrite that function. This add function now has exception handling. That's what it's called. And it will be able to handle errors gracefully. Notice that our original code is within the try block on lines 3 through 10. Any code that you have within the try block is code that can raise errors. So all of these lines of code I feel can raise an error, and that's why I've placed that code within the try block. The except block contains the code where you handle the error. So the code on lines 12, 13, and 14, that's the error handling bit. So that's what we do when an error occurs. So if an error occurs in the try block, Python's execution will directly go into the except block, and that is the code that will be executed. If there is no error, the code in the except block will not be executed. Notice how we start the try block. We have try, then the colon, and then we have the indented series of code lines, and then we have the except block. And notice the except block, except value error as E. This structure indicates that we are only handling the value error that might be thrown by the code in the try block. We are not handling any other kind of error. We're not handling name error. We're not handling type error. We're not handling zero division error. We're only handling the value error type. Also, value error as E means that whatever value error is thrown within the block, this is only if the error is thrown, that value error will be stored in the variable E. Let's actually execute this code and I'll explain further how things work. Once again, we'll ask the user to input two numbers. Let's say the user inputs 45 and T. This will cause a value error to be raised in the try block, and this will be handled by the code in the except block. So in the previous code cell, as soon as we try to convert num2 to floating point, that's when the value error will be raised. And the minute the value error is raised, the execution of the Python program moves into the except block, and the statement invalid input, please enter numeric values, is printed out to screen, and the function returns none. Let's try this again. This time I'll enter t as the first input argument, 34 as the second, and once again a value error will be thrown when num1 is converted to a floating point type. But the error, as you see, is handled gracefully by the code in the except block. Now, let's say there was no error. The entire code in the try block will be executed, and the code in the except block will not be executed at all. The program ran through successfully. Now let's write another function, this time to divide two values, and because I want to handle errors gracefully, I have the except block that handles the value error. The function divide takes in two input arguments. The code within the try block on lines 3 through 14 converts both input arguments to floats and then divides num1 by num2 and prints out the result and returns the result. If either num1 or num2 cannot be converted to floats, a value error will be thrown, which we'll handle with the code in the except block. So in the except block, we'll simply print out to screen invalid input, please enter numeric values. Notice the except block simply says value error, not value error as E. That's because I'm not storing that error in a variable. I don't really need that error in a variable, so I've just left that out. Once again, we'll ask the user to input two values and divide one by the other. So let's say the user enters the first number 45, the second number 5, we get the result 9. This looks good. Let's say the user enters 67 and E, the value error will be thrown and we get the message invalid input, please enter numeric values. So we've handled invalid inputs gracefully. Our code is pretty decent, but we haven't thought through everything. Let's say we run this code again and the user enters 23 and 0. This is going to cause a different kind of error, one that we've not handled, the zero division error. Our try except block handles the value error, but it does not handle the zero division error, which is a different kind of error, which means we need to fix this code somehow. Let's get ChatGPT's help. I'm going to copy this code over because I'm going to use it in my prompt, and I tell ChatGPT I have this function which handles non-numeric inputs. However, when I pass in 0 as the second argument, it throws an error. Can you help fix this code to handle both errors? Notice how explicit I am in this prompt. I don't want to lose the code to handle the value error, but I also want to handle the zero division error. And of course, I've pasted the entire code in here. Let's see what ChatGPT has to say. Now, ChatGPT says you can add a specific exception handler for division by 0, that is the zero division error, in addition to the value error handler, and it says that it has generated the code for you. But when I actually looked at the code, there was no zero division error handler. There was only the value error handler. And then I noticed that ChatGPT actually handled the zero division error problem in a different way. Notice the code up top. If num2 equal to 0, print error division by 0 is not allowed and then return none. So it used an if condition to check for 0 and explicitly handle that. But really, that's not what I wanted. I wanted to know how to handle the zero division error. So I asked ChatGPT a follow up question. I don't see the handling for zero division error. Did you forget to include it? And ChatGPT immediately corrects itself. You'll find that in such situations, ChatGPT is very apologetic, but it may not always give you the right answer. But in this case, it does. It said it has given us the updated code with the zero division error handling, and you can see there are two except blocks: except value error, except zero division error. This seems like code we should copy and paste into our code cell and see how things work. I'm just going to clean up this code a bit, remove all the comments and remove the invocations here at the bottom. And in order to show you how the error handling is done using the exception handler that we have defined, I'm going to get rid of this code which checks whether num2 is equal to 0. This way we are sure that the zero division error is handled by our handler. Let's turn our attention to this updated code. The code on lines 3 through 9, that's the code which can actually raise the error, either value error or zero division error. And we are handling each error separately within separate exception blocks. Within the except block for value error, we print invalid input, please enter numeric values. This is the code that will be executed if a value error is encountered. But if a zero division error is encountered, the code on lines 16 and 17 within the except zero division error block, that's the one that will be executed. And we should see the message error division by 0 is not allowed. So based on the kind of error, different blocks of code will be executed. Let's run this code and take a look. We'll accept inputs from the user as before. Let's say the user enters 4 and T, the value error would have been thrown and we get invalid input, please enter numeric values. Let's run the code cell again. This time I'll enter 4 and 0 and the zero division error would have been thrown and the code in the except zero division error block will be executed and we see error division by 0 is not allowed. And of course, the entire code in the try block will be executed if there is no error. At this point, you have a solid working knowledge of Python. You know how to work with data structures in Python. You can write functions. You can pass in input arguments to functions, get return values. You know how to do error handling. You know how first class functions work. You know how lambdas work. And you also created and instantiated classes. So with all of this accumulated knowledge, I think you're now ready to build a few simple projects in Python. And we'll start off with a data science project. We'll use the pandas and matplotlib library in Python to do some basic data manipulation and visualization. Notice I'm on the home page of my Jupyter Notebook server, and here within my current working directory, I've created a new subfolder called datasets. Within this datasets folder, I have a CSV file, insurance.csv. CSV files are files where records are stored using comma separated values. That's what CSV stands for. You can see that the data contains a number of records for different customers. For each customer, we have the age, gender, BMI, children, whether they are a smoker or not, the region they live in, and their insurance charges. This is the data that we are going to manipulate and visualize. So let's head over to the Jupyter notebook I have open in my current working directory. It's called Simple Data Analysis. And now that you're working on a project, you'll find that ChatGPT is even more helpful than it was before. So I tell ChatGPT, I have a CSV file with data on my local machine. What's the best way to load and analyze this data in Python? And ChatGPT gives me step-by-step instructions for how I can go about this. It says, import the necessary libraries, and it suggests pandas and matplotlib, and it also gives you a clear explanation for why these libraries are needed. Pandas for data handling and matplotlib or seaborn for data visualization. And it says something like you can install these libraries using pip if you haven't already, but it doesn't give us instructions for that, but it gives us other instructions. And then it asks me to load the CSV data using the pd.readcsv command, and then it gives me a number of functions that I can use to explore the data. I'm going to rely on ChatGPT heavily here, so I'm going to go ahead and run the import statement ChatGPT told me to. Import pandas as PD. This will import the pandas module or library and alias it as PD. And this immediately throws an error. Module not found error, no module named pandas. Maybe you're not sure as a Python newbie why this module isn't found. So let's turn to ChatGPT for help again. I tried to import the pandas library and I got this error. And ChatGPT tells me what's wrong because this is a very common error that everyone encounters. It so happens that the pandas library may not be available by default in your Python environment. It isn't installed by default. In order to install this library in your environment, you need to use pip, which is the Python package manager. Pip allows you to install the Python packages that you need so that you can use different libraries that Python programmers have made available to you. And the way you install the pandas library is by running pip install pandas. Now you can run pip install pandas within your Jupyter notebook or on your terminal prompt. I'm going to run this within my Jupyter notebook and get set up with pandas. So instead of importing pandas as PD first, I'm going to run pip install pandas. This will download and install the pandas library in my local Python environment, and this should now be available for me to use. If you're running pip install pandas within your Jupyter notebook, go to kernel and restart your Python kernel. This will ensure that the library will be available. Kernel restarts are not always needed, but it's always better to restart your kernel once you've installed a new module. Restart and clear outputs will start your Jupyter notebook from scratch. Let me import pandas as PD once again, and this time there is no error. Let's switch back to ChatGPT and ask it a question to move ahead. I've imported the pandas library into my code successfully. What do I do next? And ChatGPT will give you step-by-step instructions. It remembers your original objective from the current conversation thread. We need to use pd.readcsv to read in the CSV file, and then there are a variety of ways in which we can explore our data. Let's go back and perform all of these operations. The first thing is to read in our insurance.csv file. I use pd.read_csv and I specify the path to where my file lives. It's in the datasets subfolder in my current working directory. So datasets/insurance.csv. You might want to use backslash if you're on a Windows machine. This data will be stored in the insurance_data variable, and this variable will contain what's known as a pandas data frame. A pandas data frame is just a tabular representation of your data in rows and columns, as you can see here on screen. A data frame has a number of useful methods that you can use to view your data. For example, the head method takes in the number of records that you want to view and prints out that number of records to screen. Head will always print out the first records from that data set. Here are the first 10 records as we had specified. The head function actually has a default value for number of records to be displayed. If you don't specify any input argument, it will display 5 records. So here are the first 5 records from our dataset. Just like the head function, there is a separate function called tail, which again you can use to specify the number of records you want to view from the end of the data. Tail with an input argument of 10 will display the last 10 records in your dataset. And these are the last 10 records. Another function that ChatGPT had suggested to explore our data was the info function, which tells you what columns are present in your data and the type of data present in each column of records. You can see the age column contains integers in 64s and it's non-null. That is, there are no null or missing values in that column. BMI contains float 64, that is floating point values. Smoker is of type object. Anytime you see object, that means that column contains string values. Another function that our Gen AI assistant had recommended was the describe function. And describe gives you a quick statistical summary for your data. Describe operates on just the numeric columns in the dataset, and this include age, BMI, children, and charges. For each of these columns, we have the count of records 1338, the average or the mean, the standard deviation, the min, max, and the 3 quartiles 25th, 50th, and 75th. The describe function quickly computes summary statistics on your data that you can use to understand your data. Now that we have a big picture idea of the data in our data frame, let's perform some data manipulation with ChatGPT's help. ChatGPT is great at data manipulation with pandas. The more detailed your prompt, the better its response will be. So here is my prompt. I have a data frame with insurance data with the following columns, and I list the columns. How do I filter and store separately only those records where age is greater than 45? And I also specify the data frame is called insurance data. So that is the variable that ChatGPT will use to generate its code. And ChatGPT generates code that I can use directly. I'm going to copy this bit of code over, paste it into my notebook, and see what it does. Notice that you can index into the data frame using square brackets and specify a Boolean predicate. Here my predicate is insurance data age should be greater than 45. Now the filtered data will only contain records where our customer's age is greater than 45. Well, that was quite effective. So let's go back to ChatGPT and ask a follow-up question. Using the same data, how do I filter and access those records where age greater than 45 and the person smokes? So there are two conditions to my filter: age greater than 45 and a smoker. And I've asked ChatGPT to use the same data. And really, it produces perfect code here as well. I'm just going to copy this code over and run it within the Jupyter notebook. Once again, we access insurance data and use square brackets and specify the predicate based on which we want the records to be filtered. Since there are two clauses, we specify them in brackets: insurance data age greater than 45 ampersand insurance data smoker equal to yes. The ampersand is the and condition indicating that both conditions need to be satisfied, and the filtered records are all for people over 45 and who smoke. Notice the smoker column is all yes. If you can have and conditions in your filtering predicates, you can have or conditions as well. Let's try another prompt. Using the same data, how do I filter and access those records where BMI is greater than 30 or the person smokes? So if either of these conditions are true, we want to view those records. And once again, ChatGPT gives me perfect code that I can use directly. And really, I feel data manipulation with pandas is one of ChatGPT's strengths. And I find it incredibly useful to use these techniques in my real world projects as well. We index into the insurance data frame, and we find records where BMI greater than 30 or an or is represented using that pipe operator. The person is a smoker equal to yes. The filtered data frame will contain records where either of those conditions are true. For example, record 0, you can see that the person is a smoker, but the person's BMI is less than 30. But record 1, the person is not a smoker, but his BMI is 33.77, so greater than 30. After performing a few filtering operations, let's see how we can perform other kinds of data manipulation. Here I am back on ChatGPT, continuing with the same conversation. Using the same data, how do I select only the BMI smoker region and charges columns from the data frame? So instead of filtering records, I want to filter on certain columns I'm interested in. And ChatGPT gives me the correct syntax to do exactly what I asked it to. Let's select this particular bit of code. This is the only bit of code that I need, and paste it into our Jupyter notebook. Notice how we use the double square brackets to extract these columns that we are interested in into a separate data frame called selected columns. Let's take a look at selected columns, and you can see that it has just the 4 columns that we had mentioned when we performed our selection. Rather than selecting the columns that you're interested in, let's say you wanted to actually get rid of some columns that you're not interested in so that you're left with the remaining columns. Here is a prompt that can help you achieve this. How do I trim the data set so that the children columns is not included? So that's the column that I'm no longer interested in, the children columns. And you can see how we can trim our data. We'll drop the children column, all of the other columns will remain. Let's copy this over and execute this code in our code cell here. Notice that we use the drop function on our data frame. Insurance data.drop will drop the column specified and return a data frame with the remaining columns. Here, the trimmed data frame gives us all of the columns except children. We've seen how we can filter rows and select columns. Let's move on to some other data manipulation techniques. Let's go back to ChatGPT, and here I'm now curious about whether I can compute the average insurance charges for smokers and non-smokers. This is what I've asked ChatGPT here in my prompt to see whether I can get this aggregated data, and it gives me the perfect code to perform this computation. Let me copy this code over, and when I paste it into my Jupyter notebook, we'll try and understand what this code does. ChatGPT also gives me code here below on how I can access the charges for smokers and non-smokers once I've computed these charges. That's this second bit of code. Let's copy the first bit of code where we perform our grouping and aggregation operation. Insurance data.group by allows us to group our data based on a particular column. And here I've selected the smoker column. This will group all records based on whether the customers are smokers or not. And then in the grouped data frame, we access the charges column using square brackets, and then we compute the mean or the average of charges. The result is stored in the average charges variable, and let's take a look at its contents. And you can see that the average charges for smokers is so much higher than the average charges for non-smokers. Average charges here is a grouped data frame, but how do you actually access the values corresponding to yes and no? That's the second bit of code that ChatGPT had generated. Let's copy that over and let's paste that into our notebook cell. And I'm going to add in print statements so that the average charges for smokers and non-smokers will be printed out to screen. Looking up yes in the group data frame will give us the average charges for smokers, and we know that that's almost $32,000. And looking up no in this group data frame will give us the average charges for non-smokers. That's just about $8,400. So far, we've used pandas to do some basic filtering, selection, grouping, and aggregation. Let's turn our attention to something slightly different. This time, data visualization. I want to use charts to visualize the relationship between the different columns in my data. So I turn to ChatGPT and ask, how can I visualize the relationship between BMI and insurance charges? I'm curious to see whether BMI influences how much a customer is charged. So I type in this prompt, and you can see that ChatGPT has generated some visualization code and some explanations. Observe that I did not tell ChatGPT how I want to visualize this relationship using what kind of plot. I just specified the columns, and ChatGPT correctly picks the kind of plot that you'll use to visualize the relationship between two continuous values, a scatter plot. So you may not have known this is the right plot to choose, but ChatGPT has pick the right one for you. Scatter plots are useful for visualizing the correlation or distribution of two continuous variables, and you get this additional helpful information that you can use the matplotlib library in Python to create this scatter plot. And it gives you the code for importing matplotlib and setting up the scatter plot. First, let me just copy over this import statement to see whether matplotlib is available on my machine. Now, if you don't have matplotlib as a part of your environment, you'll see this module not found error. This means that this particular library has not been installed in your environment, and you can get it with a pip install. This is something that we had learned earlier. Once you've installed a new Python module, you should restart the kernel. And after restarting the kernel, let's run the import statement once again. Import matplotlib.pyplot as plt. .pyplot is a library within matplotlib. And this time around, your import should be successful. If you encounter no errors in your import, it means that the matplotlib library is already available. Once we've taken care of that, let's head back to ChatGPT and let's copy over the code that actually displays a scatter plot. Remember, this is the best chart to see the relationship between two continuous values. I've copied over the code here and added a few new lines so that we can clearly see what's going on. Let's try and understand this code. A matplotlib chart is displayed within a figure and have specified the figure size to be 10 inches by 6 inches. 10 will be the width and 6 will be the height. Next, within this figure, we'll plot a scatter plot using plot.scatter. That is the function to invoke. The first input argument is the variable that you want represented on the x-axis, that is the BMI in the insurance data. The second input argument is the variable you want represented on the y-axis, insurance charges. Alpha here specifies the transparency of the scatter plot points. An alpha of 0.5 indicates that the plot points will be semi-transparent. The title of the plot, BMI versus insurance charges, the x and y axis labels, plot.grid true will show a grid for the plot, and plot.show will actually display the plot. And here is what the scatter plot looks like. Let's scroll down and take a look. We have BMI on the x-axis, insurance charges on the y-axis, and from the shape of the scatter plot, there's definitely a linear relationship between BMI and insurance charges. As BMI rises, insurance charges also seem to go up. Now, let's say there is another relationship that you're curious about. We'll turn to ChatGPT and ask for a visualization to view this. Using the same data, how can I visualize the relationship between smoker and insurance charges? Smoker is a categorical variable, meaning it can be one of a discrete set of values. So the only values for smoker are yes and no. Insurance charges is a continuous variable. I haven't specified to ChatGPT what kind of visualization to use to view this relationship, but ChatGPT picks the right one, a box plot. A box plot is a great visualization that allows you to see the relationship that exists between a categorical variable and a continuous variable. So I'm going to copy that bit of code over. You can see the explanation for that code here, and I'm going to paste it into our Jupyter Notebook cell. And let's see how the box plot is set up. Once again, ChatGPT has generated code using matplotlib. So we know the common elements plot.figure to set the size, title, x label, y label, and plot.show to display the plot. The plot.boxplot function takes in 3 input arguments. First, all of the records where smoker is equal to yes and the charges for those records. That's the first input argument. The second input argument is all of the records for which smoker is equal to no and the charges for those records. And the third input argument is the labels for these two categories, and the labels are just smoker and non-smoker. Let's take a look at this box plot, and you can see that overall, smokers pay a lot more in insurance charges as opposed to non-smokers. The central line in each box is the median of charges for smokers and non-smokers. The size of the box represents the interquartile range for smokers and non-smokers, and the whiskers of the box, the little horizontal lines you see at the top and bottom of the box, well, those are whiskers and they are 1.5 times the interquartile range away from the edges of the box. That's the default. You can see that both the median and the interquartile range for smokers is much higher than for non-smokers. Now, somebody in your team might say something like, a better library to use for statistical visualization is Seaborn. Rather than just Matplotlib, you should use Seaborn for visuals. You can convert this visualization to use Seaborn by asking ChatGPT to rewrite the code. Could you rewrite the code for the box plot using the Seaborn library? And ChatGPT will give you instructions for using Seaborn. Seaborn is a library that is built on top of Matplotlib, but it's much easier to use than Matplotlib. It's maybe less configurable than Matplotlib, but you'll find that the visuals look much better. Seaborn is a separate library, which means you need to pip install the Seaborn module before you can actually use Seaborn. Once the installation is complete, you can go ahead and import Seaborn, and that's typically done using an alias, import Seaborn as SNS. Once you've installed the module and restarted the kernel, import Seaborn as SNS should work perfectly. You should not encounter an error. And with that done, let's copy the code for the box plot using Seaborn. Let's set up and take a look at this box plot. Since Seaborn is built on top of Matplotlib, Matplotlib type configuration works with Seaborn, such as plot title, plot x label, plot y label, and plot show. To plot the box plot, all you need to do is call sns.boxplot. X-axis is the smoker column, y-axis is the charges column, and the data to operate on is the insurance data. And that's it. This will generate the box plot. If you encounter the same warning when you run this, you can ignore that. This is a bug in the latest version of Seaborn, which should be fixed in the next version. And here is the same box plot for insurance charges by smoker status, but notice that it's automatically better formatted and has better visuals than when you just use plain vanilla Matplotlib. In this demo, we'll work on another mini project in Python. We'll see how you can use HTTP requests within your Python program and make HTTP requests to access data on a web server. We'll see how you can make GET requests used to retrieve data from a server and also make POST requests used to update data on the server. There are different types of web requests that you can make using HTTP, but we'll only look at the GET request used to retrieve data, POST requests used to update resources. Now, in order to hit the server needs to expose some kind of API that we can use to call the server from our Python program. Web servers usually make the data that they have available accessible to us using REST APIs. REST stands for Representational State Transfer. APIs, stand for Application Programming Interfaces. REST APIs provide a standardized way for applications to communicate with one another using web protocols such as HTTP. Here I am on this URL called jsonplaceholder.typecode.com, which exposes a bunch of REST APIs that we can use to test out our HTTP requests. You can see on the screen that JSON placeholder provides a free fake API for testing and prototyping. And that's perfect for us. This will allow us to see how we can work with web requests. This page, JSON placeholder, contains documentation for what URLs you can hit and what kind of data you can retrieve from these URLs. For example, the /posts URL gives you a list of 100 posts in the JSON format. So if you were to make a GET request to this URL, jsonplaceholder.typecode.com/posts, you'll get a JSON response with a list of 100 posts. If you haven't worked with JSON before, JSON stands for JavaScript Object Notation, and it's a lightweight data interchange format that is very easy for humans to read and write, and it's easy for machines to parse as well. Notice the opening square brackets that indicates the start of a JSON list. In this list, there are 100 posts where each post is enclosed within a pair of curly braces. So each post has keys and corresponding values, just like a Python dictionary. Notice that each post has the attribute user ID, title, and body. We'll make a GET request from our Python program to this URL, retrieve and parse this JSON data. Another URL I'm going to work with is the /todos URL. The complete URL is jsonplaceholder.typecode.com/todos, and this returns a list of to-dos in the JSON format. We'll access this URL and parse this request as well. On the main page of the JSON placeholder site, you should find a user guide for how you can make different kinds of requests: GET request, POST request, PUT, delete, and other requests to the different URLs, and what kind of response you should expect from the URL. Making these requests often involves passing a bunch of different information about the method, the body of the request, the headers. All of these examples are in JavaScript. We'll of course be using Python with ChatGPT's help. Let's head over to ChatGPT and specify a prompt. We know the URL to which we want to make the request. So I tell ChatGPT I need to make an HTTP request to retrieve data from this API, and I specify the JSON placeholder /post API. Could you guide me on how I can do this in Python? And ChatGPT suggests the library that I can use and also gives me code actually making the request and parsing the response. We need the request library and we need to pip install it first. So go ahead and copy the pip install command and install this library in your local environment. You can ignore the red error that you see here. That's only on my local machine because I have some other libraries in the same environment. You should see a completely clean black output. The next step is to import the request library so that we can use it and also specify the URL in a separate variable. So I import request and I store the URL of the API that I'm about to access in a separate variable. Let's copy the rest of the code over. And you can see that the entire code is in a try except block. And again, because this is a fairly common and basic scenario, you can use the code that ChatGPT generates directly. Now, when you make HTTP requests, you're very likely to encounter errors if the server is down. And that's why the entire code is within a try except block. You can see the try on line 1 and except on line 19. We've imported the request library and request.get makes the HTTP GET request to the URL. The response from the URL is stored in the response variable and we check the .status code property of the response object. If the status code is 200, this means the response was successful and we parse the JSON response. Response.json will give us the JSON response. And on line 13, we access the title property of the very first post and then print that out to screen. If the status code is not 200, there was an error, so we print out HTTP request failed with status code. If an exception occurs, that's handled by the code on line 21. Let's run this code and you can see the title of the first post. We've successfully made an HTTP GET request and parsed and retrieved the response. But what if you want the response to be a little different? So I go back and ask ChatGPT a follow-up question. Could you update the code to extract the title and body of each post? Both of these are attributes in a post and print that out to screen. We want ChatGPT to modify the code that it had previously generated to perform this parsing. ChatGPT gives us the updated code that I'm going to copy over only the try except block, not the rest where we initialize the URL. And let's paste that into a notebook cell. Most of the code is exactly the same as before. The new lines of code that have been added are on lines 10 through 14. This is where there is a for loop that ChatGPT has added to iterate over the JSON list of posts that's returned. And for each post, it extracts the title and the body and prints that out to screen. Let's go ahead and run this code. And you should see for 100 posts, the title and body displayed here in the result. Back to the main JSON placeholder page. Let's scroll down and retrieve data from a different URL, the /todos URL. The entire path is JSON placeholder.typicode.com /todos. And this returns a list of 200 to-dos where each to-do has a user ID, title, and whether the to-do was completed. I'll now turn to ChatGPT once again and specify detailed instructions to access and parse these to-dos retrieved from the URL. I prompt using comments because I find this technique easier to create step-by-step instructions. I specify the URL which returns the JSON response /todos. Next, I specify the fields in the response. This makes up the context of the prompt. Then I ask ChatGPT to retrieve the data using a GET request, and then I have an output format in which I want the data. I ask ChatGPT to parse the result and place the result in a pandas data frame. So you can see that this request is fairly detailed. Observe that ChatGPT tells me to pip install the required libraries, requests, and pandas, and then it has generated a bunch of code that I'm going to copy over. Let's take a look at the code here in Jupyter Notebook. I have the import statements up top. I've already imported requests, but I just re-imported. I have the URL that I want to hit /todos. Request.get makes a GET request to the URL. We check the response status code if it's 200. If it is, we get the JSON response and pass that into a pandas data frame. Pandas knows how to parse the JSON response and convert the contents to a data frame. And then we print out that data frame. Let's run this code. And here we have the df data frame with the contents of the response. And you can run df.head and see the response in a data frame format, the first 10 records. Now that we know how to work with GET requests, let's see how we can work with POST requests. Let's go to the main JSON placeholder page and click through to the guide where you can see the different requests that you can make to APIs. An HTTP POST request can be used to create a resource on the server. And you can see that the POST request can be made to the same /post URL. When you make a POST request, the server is not actually updated, but you receive a response as though the server was indeed updated. So you kind of get a fake update. That's because this is just a fake API. Let's set up our prompt to have ChatGPT generate code for a POST request. We specify the URL, JSON placeholder, typicode.com/post, which accepts POST request to create new posts. Please write code to access this URL using a POST request. Now, if you're creating a new resource on the server, you need to send the contents of that resource. So this is done via something known as the body of the POST request. So I've asked ChatGPT to add a post with title, body, and user ID. These are the attributes of a post. And then I want ChatGPT to parse the JSON response we get from the POST request and print that out to screen. And ChatGPT very helpfully generates the complete code for us. I'm going to copy this code over and paste it into a cell in my Jupyter notebook. The URL is /post. The new post data is defined as a Python dictionary on lines 8 through 12. So we have the title, body, and user ID. The post request is made within a try block on line 16. Notice we post to the URL and specify the body of the post request using the JSON input argument, JSON equal to new post data. A successful post request returns the status code 201. We check for that, get the JSON response, and dump that out to screen using json.dumps. JSON is just another module in Python, and you can run this code and you can see that the post request was successful. We made HTTP requests to URLs and we had ChatGPT generate all of the code for this. We didn't write a single line of code on our own. So far, we've been running our Python code on Jupyter Notebooks, but now for this last demo, we'll switch over to the terminal and see how we can run Python scripts on the terminal. Let's make sure you can access Python from the terminal. If you simply type Python, this should take you into an interactive code shell for Python. Type exit in this code shell, and that should bring you back out. If you manage to do this successfully, you have Python installed on your machine. Let's get some Gen AI help with our very first Python script to be run from the terminal. Let's give Bard some details. I've been learning Python using Jupyter Notebook so far. I think I'm now ready to write a simple Python script that can be executed using the command line. Could you generate code for my very first script and explain what it does and how to run it? A hello world script for the command line. We're just getting started after all. And very helpfully, Bard gives me a simple Python script which has only the bit of code print hello world. And Bard also shows me how I can run this script by running python hello world.py on the command line. And that should print out hello world to screen. We're ready to try this out. I'm going to copy this code over and use a simple text editor to write my code. Here I've chosen Sublime Text. But really, because we are going to be working on very simple programs, you can use Notepad or any text editor of your choice available on your machine. I'm going to save this as hello world.py in my working directory learning Python. In order for Python to understand this is a Python script, make sure you name the file with a .py extension. That is very, very important. I'll now switch back to the terminal window after having saved the file. ls-l shows me that hello world.py is present here. Let's now execute this script. Python hello world.py should run this script and you can see hello world is printed out here to screen. Our very first Python script was easy to generate and execute. So we can get a little more ambitious and I turn to Bard once again. I specify detailed instructions using chain of thought prompting so the instructions are followed step by step. Could you write a Python script to be executed on the command line? accept two numbers from the user, invoke an add method to print out the sum of those two numbers, and the add method should convert the input to numeric values and have appropriate error handling. So this is a pretty detailed set of instructions. What I'll do now with this Python script is copy this code over and paste the script into a file that we'll then name with the .py extension. And once we've done that, we'll examine what this script does. Let me first save this as add numbers.py in my current working directory, and this will add syntax highlighting to the script. Because Sublime Text, my editor, now knows that this is a Python file. Here is the add function on top that accepts two input arguments, num1 and num2. On lines 4 through 12, notice that Bard has generated documentation for this function as well, which is great. Now, the code where we convert the input arguments to numeric form, the code on line 16 and 17, are enclosed within a try except block because this code can throw exceptions. The code on line 16 and 17 converts the input to numeric values. If there is a value error, we simply raise the value error again with a different message. Invalid input, please enter two numbers. In an earlier demo, we learned how to handle exceptions. Here is an example of how you can throw your own exceptions. On line 20, we use the raise keyword to throw the value error exception when the input is invalid. If the input is valid, the code returns num1 plus num2. The script contains a second function called main that actually invokes the add function. Name uses the input function to accept the first and second numbers from the user. Main then invokes the add function and stores the result in the sum variable. I've told you before that using sum as a variable is actually wrong because sum is a built-in function in Python, and when you use it as a variable, you're actually overwriting that built-in function. For now, we'll just accept this as is, and we print out to screen the sum of two numbers is and the sum. Now on line 36, you might see some strange bit of code that you don't understand. If dunder name dunder is equal to dunder main dunder. Don't worry about this right now. I'll explain this to you in due course. Essentially, this if will be true when we actually run this script, and that will cause the main function to be invoked, which will accept input arguments from the user and call the add function to perform the addition. Make sure you save this file and switch over to the terminal window, and let's invoke the script. Python add numbers.py. The first number I enter is 34. The second number, I'm going to enter a floating point, 98.3, and I get the sum of two numbers, 132.3. And you can actually enter invalid values and make sure that your code works. Let's run the script again. I enter 45 and H, and I get the value error that I throw, invalid input, please enter two numbers. Now let's say you don't want this value error to be thrown. Instead, you just want to print out to screen that you've entered an invalid input. Just change that to a print statement. I'll make a few more changes here. Instead of adding the two numbers outside of the try block, I'll move that code to be inside of the try block. Also, within the except block, I'll return none so that there's always a value returned from this function. In addition, here when I invoke the add function, I'll check to see whether the result is none. Only if the result sum is not equal to none will we print out the sum of two numbers to screen. As you can see, Bard produced great code for us, but the code wasn't perfect. I had to make a number of tweaks to the code to get the code exactly right for my particular use case. And you'll find that this is often the case for you as well. When you're actually using generative AI to generate code for your projects, make sure you tweak the code to meet your needs perfectly. Now that we've tweaked the code, let's run this and let's enter two numeric values and make sure that add numbers works perfectly. And you can see that it does. It gives me the sum of two numbers with numeric values. Let's try entering an invalid input. I hit 34 and then let's say I enter the character Y. I simply get on screen invalid input. Please enter two numbers. As you've been going through this learning path on learning Python using generative AI tools with me, you've seen that ChatGPT, Bard, and other Gen AI tools can get things wrong. For most of the basic cases, they are spot on, but they can get things horribly wrong, which is easy to spot, or they can get things subtly wrong, which is much harder to spot. As a newbie, the code on line 35, sum equal to add num1, num2, might seem completely okay. There's nothing really wrong there, but it's actually wrong because sum is a built-in function in Python. And when you use sum as a variable, you lose access to sum as a built-in function. Let me show you this with an example. I've added a bit of code here on line 40 and I'm trying to compute the sum of 99 and 101 and I've passed those in as input arguments. Now this is actually wrong because the built-in sum function takes in an iterable such as a list. But maybe you don't know that's what it does and you just pass in two input arguments 99, 101 and expect sum to work. Now, sum is not going to work for many reasons. Let's see if we can use ChatGPT to debug all of this. I call add numbers.py and let's specify two numeric values. Let's say we specify 43 and 98.6 and this results in a type error. Float object is not callable. And you can see that the error is because of this print function that we added where we invoke the sum built-in function and we get float object is not callable, and let's say this is really flummoxing us. You may have used sum as a variable somewhere else in your code and then you invoke the sum built-in function far away from where you've used sum as a variable, and then this particular error can be quite perplexing. Let's turn to Bard and see if Bard can help us dig ourselves out of this hole that we are in. I tell Bard, I used the code that you generated and that was totally fine, but when I added this additional bit of code, this print statement, where I invoke the sum function with the two values 99 and 101, in the main function I get this error. Type error, float object is not callable. Let's see if Bard can help us debug this. Now, Bard correctly tells me that float object is not callable means that you're trying to call a floating point number as though it were a function, but floating point numbers are not actually callables. They're not actually functions. But Bard also looks at the line of code that I've added and points out something else. You're trying to call the sum function with two floating point numbers, 99 and 101, but the sum function takes in an iterable as an input, not two individual numbers. Bard has also figured out that I'm calling the sum function with wrong input arguments, and it gives me code on how I can actually correct this. Here is the corrected code. I should actually be invoking the sum function and pass in 99 and 101 inside an iterable such as the list. Notice the square brackets that Bard has specified in the code. I'm going to make this change in the code that we have here. I'm going to pass 99 and 101 inside an iterable, that is a list, and let's try adding two numbers yet again. I call Python add numbers.py and I pass in two valid numeric arguments 3 and 5 and I still get the error float object is not callable. Now you might be even more confused at this point in time. You took Bard's advice and invoked the sum function with an iterable. Why does this still not work? Well, let's go back to Bard and tell it that things are still not working. Here is my follow-up conversation with Bard. I changed the sum function to take in an iterable, but I still get the same error. And so that this time Bard has more context to debug, I paste in the code for the entire main function. I'm hoping this extra context will get Bard to put me on the right path. But it turns out that Bard still doesn't get it. It says that it sees the problem now and it's very confident in its response, but it goes on about you're invoking sum twice, but you're printing out the second response before the first, and then it generates some code that should work, but the code is exactly the code that I have now, which does not work. I included this little demo towards the end of your learning path to show you that there are subtle bugs that generative AI will not help you fix. And this is where your knowledge of Python, your intuition, and your intelligence really wins over these Gen AI tools. Bard just does not know that when you use sum to store the result, you're using it as a variable, and that's actually causing you to hide the built-in sum function in your code. This is a very, very subtle point. Newbies get tripped up on this, and so does Bard. So, Bard is not going to help us fix it. So, we are going to use our intelligence to fix it. So, instead of using sum as a variable, let's call the variable result. And I've made the change in my code here. Sum is no longer a variable, it's still a built in function. So, the code on line 40 should print out the sum of 99 and 101. Let's try this by running this code here in our terminal window. I'll be prompted to enter two numbers. I'm going to enter two numeric values. I've entered 4 and the second number is going to be 7. Notice the sum of two numbers is 11. Notice also the sum of two numbers, 200. 99 plus 101 is 200. That line of code was successfully executed and the two numbers were summed up using the built-in sum function. Because sum is no longer a variable, you can use sum to reference the built-in function that Python offers. You've seen earlier how import statements allow you to reuse Python code that other Python developers have written and made available to you as modules or libraries. In this demo, I'll show you a very simple example of how you can split your Python code to be in different modules and then import your own modules in your main program. But before we do that, let's try and understand what's going on here on lines 43 and 44 of our addnumbers.py file. If dunder name dunder equal to dunder main dunder, what does that mean? I'm going to head over to Google Bard and ask it to explain this particular line of code to me. What does this mean in my Python file? And Google Bard gives me a very good explanation. Every Python file that you write is a separate Python module. Any script that you execute on the command line using the Python function is considered to be the main module for that execution. So this if check that we've added there, if name is equal to main, is used to check if the current module, that is the current Python script, is being run as the main program. If that's the Python script that you're executing as your main program using Python and the name of the script, well, then the name of your module will be equal to main, that if condition will be true, and whatever you invoke within that if condition will be executed. The dunder name dunder variable is a special variable in Python that contains the name of the current module. Now, this may not make complete sense to you yet. Let me show you how this works with an example. Let's go back to our Sublime text. Here I have my addnumbers.py function with the same code as before. I'm going to get rid of this extra code here where we print out the sum of 99 and 101. We know that this Python script contains the add function. Please note that I still have the code on lines 41 and 42. If name is equal to main, only then invoke the main function in this script. Now I've added another file called subtractnumbers.py. The only difference here is that I've defined a subtract function, and you can see the code on line 20. We return num1 minus num2. The rest of the code is the same. There is a main method that invokes subtract, and then on lines 40 and 41, if name is main, only then is the main method invoked and this script executed. Now both these files, addnumbers.py and subtractnumbers.py, are in my current working directory. What I really want is to have a separate main program that, based on the operation that I specify, will either invoke add or subtract from these two files, add numbers and subtract numbers. I do not want to invoke the add number script to perform addition and the subtract number script to perform subtraction. Instead, I want to invoke a single script and specify plus and minus to actually perform addition and subtraction. Let's see how we can do this, and I'll take Bard's help here. Because I want Bard to generate as much of the code as possible and as correctly as possible, my prompt is very detailed. I have two different files named add numbers and subtract numbers. They have the functions add and subtract respectively. Each of these functions accepts two input arguments. The functions have all of the error handling needed for non-numeric arguments. That's the context. Now I have my instruction. Could you write a program that imports these functions and invokes them? The program should request the user for two numbers and the operation that the user wants to perform. So the write function will be invoked based on the operation that the user specifies. Let's see what Bard has to say in response to this. And I should tell you that the code that it generated was near perfect. It was code that I could use directly. And this really is because of the detail I had specified in my instructions. So I have copied this code over into a new script file, and I'm going to call this main.py. This is going to be my main Python program that invokes the other modules, add and subtract. Notice the import statements on lines 1 and 2. Import add underscore numbers and subtract underscore numbers. These reference the name of the modules and the names of the modules are the same as the file names. Now, both of these files are in the current working directory. That's why we can directly import those files like you see here. Bard has then defined a main function that prompts you for the first number and the second number. This is the code on lines 9 and 10. Notice that Bard converts these numbers to numeric values, even though we said that this conversion is done in add numbers and subtract numbers. Let's leave that for now. Bard then prompts you for an operation to perform, plus or minus. This is on line 13. If the operation you specify is plus, then the code will call add numbers dot add. So the add function that we've defined in the add numbers module, our script file, that's what will be invoked and the result printed to screen. If the operation we specify is subtract or minus, then the code will call subtract numbers dot subtract and print out the difference. Otherwise, we'll print out invalid operation. And on line 25, we have this check. Only if this program is run as a main program will the main function be invoked within this script file. Now, let's save the changes that we've made here and let's run main.py. I'll run ls-l. You can see main.py is in the same folder as add numbers and subtract numbers. Let's run main.py and let's enter two numbers. First number is 378. I specify plus as the operation and it gives me the sum as 81. Let's run the script once again and specify two more numbers, 23 and 45.3. I specify minus as the operation and it gives me the difference between these two numbers. And if you were to try and specify an operation which is not plus or minus, well, you'll get invalid operation printed out to screen, as you can see right here. We've successfully managed to write our add and subtract code in two different script files corresponding to two different modules, import those modules in main.py, and invoke those functions based on user input. Let me tweak those import statements that we added to the main.py file. Instead of importing the script directly, you can say from add numbers import add and from subtract numbers import subtract. This will only import the two functions that we actually invoke from this main.py code. You'll also have to change how you invoke add and subtract. Now you can simply call add and subtract directly. You don't need to specify the name of the module. Save these changes. You can run the code now and see that everything works as before. What I'm going to do now is switch over to the add numbers.py file and show you the importance of this if check. I'm going to get rid of this if check so that the main method is invoked even when add numbers.py is not run as the main module. I'm also going to make another change. I'm going to change the prompt here where this particular file asks for you to input numbers. I'm going to say in add numbers so we can differentiate this prompt from the prompts in main.py and subtract numbers.py. Now here in add numbers, we do not have the guardrails invoking the main function only when this is run as the main program. I'll do the same in subtract numbers. I'm going to get rid of this if check that will invoke the main function only when this is run as the main program. I'm going to invoke main directly. In addition, I'm going to change the prompt to say in subtract numbers so you know when this particular code is executed. You can differentiate from this code, the code in add numbers and the code in main.py. Now, let's switch over to main.py. You can see that main.py also prompts us to input the first and second numbers. This is the code on lines 9 and 10. Now, let me tell you what's going to happen so that you understand what's going on. Notice the imports that we have on lines 1 and 2. What those imports do is bring in all of the code in add numbers.py and subtract numbers.py into this Python script main.py. And when that import happens, the code in those files will be executed. And because we've gotten rid of that if check to execute the main function only if add numbers and subtract numbers are run as the main module, you'll find that the code in add and subtract will be executed even when you're running main.py. This will become clearer when I run the code. I'm going to run main.py, but notice that the code in add numbers is run. The main function in add numbers was executed when we imported the add numbers module. And that's not what we wanted. We only wanted the main function in main.py to be executed. Next, you'll find that the main function in subtract numbers is also executed. This happens when we run the import statement. And finally, the code in main.py is executed, and based on our plus operation, the two numbers were summed up. So if you have code that will run in modules that can be imported, you should have the if name is equal to main check, or you should not have any executable code. Remember, functions are not executed unless they are invoked. So I'm going to get rid of this invocation, and then things will work as expected. So I'm getting rid of this main invocation in add numbers as well as subtract numbers. The main invocation is only present in the main.py file. And now when you run main.py, only the code in main.py will be executed, and add or subtract will be invoked based on the operation you specify.